Hi folks, and welcome to today's lesson in BCIT's Technology Teacher Education 4010 class. This is an introduction to programming using VEXCode VR today, but we're also going to take a little bit of a look at something called Scratch, and then we're going to really dig in deep with the Arduinos. And some of the stuff that we're learning here in our early weeks is going to be applied to other things that we're doing. And by the time you get to second year, you'll be making a robot that looks something like this for me. And this is something I call the BoomBot. And as you can see, it's got an Arduino slapped on there. And so you'll be putting code onto the Arduino and you'll be reading edge sensors, much like your color sensors in VEXCode VR. You'll have encoders. In this case, we've got a little reflective sensor right here that can count the spokes as they go past because they'll reflect signals back into there. This one's got a range finder, so you can see the distance to something off in the distance. In this case, an ultrasonic range finder right on there. And this one also has a Wi-Fi connection right here. So ultimately, you can drive it from your phone or actually from anywhere on the planet if you configure it correctly. So there's a lot of neat stuff that's going on right in here. And in fact, as I talk to you right now, I'm in the process of redesigning this and changing the plans up. And this is a prototype chassis that I've come up with. And I'm still working on the CAD and the circuit board for this. And this is going to be the BoomBot version 2 that you guys will probably be working on next year. And hopefully this year's class will be working on this. And a lot of the programming concepts that we get from VEXCode VR are very applicable to what we're going to be making those machines do. And one of those concepts is thinking about your algorithms to try and simplify the instructions that you have for your robot so that they work as efficiently as possible. You try to think about your programming, I don't want to say as lazy as possible, but you want to be as efficient as possible. And you want to break things down and think about how they actually come together. So today we're going to take a look at how we can use subroutines and variables to make our programming more efficient in VexVR. Now, a subroutine is, in VEXCode VR, they call it a block. Okay. Um, in other programs, they might call it a function. But basically what it is, it's a set of commands that you can call repeatedly. So it stands off from your main program. It's part of your main program, but it sort of stands off to the overside. And what you're really doing is you're making your own command. So for instance, in here, there's a command that says drive forward for blank millimeters that you used a lot when you were creating your initials for me. Well, you can create your own command that says draw a square. Okay, and you can say make the square however long you want on each edge. And so there's all sorts of commands that you can create. And if the command you need doesn't exist, then make it. And that goes into a subroutine. Now, in order for your subroutine to do what you want, you're going to have to pass it some information. And that information is stored and passed back and forth in something called a variable. Now, when we get into talking about the Arduino, we're going to talk about types of variables that are a little more complex. We'll have things called integers or ints, and we'll have float, point, spell point right here while I'm writing it out, floating point variables, and we'll have long variables and signed variables and unsigned variables and car variables, and then we'll get into the whole world of arrays and it'll get more complex, but really in VEXCode VR, which is part of what makes it such a great introduction, there's only one type of variable and it's a number. And in fact, it's what type of variable that we call an int, an integer. It's a whole number. So it's not going to keep track of decimal places for you. Okay, so rounds off to the nearest whole number, and that's it. So there's a more complex world of variables that we can talk about later on. But right now, we're going to talk about a subroutine and a variable, and we're going to use that in the context of getting VEXCode VR to draw a square for us. Now, drawing a square is a pretty simple challenge. We know some things about the square. It's got 4 sides, okay, and each side has equal length of L. So when you tell a robot to go out and draw a square, if you're starting down in this corner and your robot's pointing forward in this direction, you could tell it drive forward for a distance of L. Turn right 90, drive forward L, so it would drive up to here, it would turn, it would drive over to here, turn right 90, so it would point down this way, drive forward L, turn right 90, and drive forward L. Now, one of the advantages of writing that out by hand is that you get really bored of writing that out by hand because you're writing the same thing over and over and over again. And if you're writing the same thing over and over again, maybe that's a sign that there's an easier way to go about doing it. And yeah, those of you who've done a little bit of programming before are going, yes, Jason, there is. And those of you who just know me say, yes, he's leading up to that. But if you look at this, what we've done is we've really done these 2 commands right here, and then repeated them 4 times. Drive forward L, turn right 90, drive forward L, turn right 90, drive forward. Oh, and then we've got one more turn. Right 90 down here to get it pointed back in the same direction we were when we started. Okay, so this is where we've got that repeat block in VEXCode VR that comes in really handy. So we could simplify this down and say repeat for, and then inside that repeat for, drive forward L, turn right 90. Now, if I set this up as a block, okay, and I call this command, I am going to pass it a variable for L. So I'd be able to say, let's call this block was called my square. I'd be able to have a square command, and I'd say square 50, and it would draw me a square with a length of 50 on each side. And if I wanted a square with a length of 500, I'd say square 500, and I'd call that square. So let's take a look in VEXCode VR how we'd go about doing that. So let me just make this screen a little bit bigger for you here so you can see what's going on. There we go. And there's my VEXCode VR screen. I was doing something else here. I wanted to get my robot to the middle of the screen. And the middle of the screen from where you start is at 900 over and 900 up. But if you do a little bit of math on that and you want to get to the exact middle of the screen, you can do some Pythagoras, and that is 1273 millimeters at a 45-degree angle. But that's not where we're going. I want something new in here. So file, new blocks project. I'm going to discard all that. We can come back to it later. And here we go. We're in a VEXCode project. We've got nothing on the screen right here. And we're going to take a look at creating a subroutine and using a block to do that. Now, if you scroll all the way down to the bottom right here, you'll see that you've got right in here, you've got make a block, my block. Make a block right on here. Click on this, and block name pops up. So you get this screen right here, and we're going to call this block square. Okay, now we want to be able to pass a value into that routine so that we know how long the edge of the square is going to be. So I click on add an input, and it's got space for a number right here. And where we drew all that out and we planned everything, we said this is going to be the edge of a square, so I'm going to call that number L. Okay, so it says square L, and I can put this anywhere on my grid because it doesn't really matter, because when we start the program, we're going to go through here, and the only time we'll come over to the square is when we tell it to by putting that square block in right there. Okay, so let's go ahead and program our square to do what we said we wanted it to do. Well, we said we wanted it to do something 4 times in a row, so we can come up here and we can say repeat 4 times, and then we were going to drive forward. Okay, now here it says for 200 millimeters. Where we have a number like that typed in, that's something that we call a constant, because that number is never going to change. But where we put a letter in its place, just like math class, that becomes a variable. Okay, so now L can represent any number that we pass over and put into there. We tell the computer what L is, and it goes through and does our bidding. All right, now of course we're going to have to turn, right, for 90 degrees. There we go. And now when we call the square routine, it'll come in here, it'll do this 4 times using whatever value we give it for L. So, okay, when started, let's give this a test. What I can do right now is I can say square, and let's make it do a square with 200 millimeters on each edge. Now we've got a brand new command in VEXCode VR. There we go. Now it drew a square. That was very nice. I'd like to see that square a bit more. So now I'm going to come down here and where am I? Right in here. Let's put our pen down so that we can track that. Move robot pen down, and tell you what, we'll just do that when we're inside the square routine. Okay, so we'll put it down here and the robot will put the pen down, and then when the robot's all done, we'll move robot pen up. So the only time we're drawing is when we're drawing a square. If you wanted, you could have another variable and you could tell it what color to draw in. You can get fancy with all sorts of things like that, but we're just going to leave it like that for right now. It's going to go and draw that square. And now we can have multiple square commands in here too. So I can do a square of 200. And now if I want to run that square again, I can make a square of 400. Okay, and let's take a look at what that's going to do for us. There we go. What a lovely square. And there we go, a larger square. Now, if I wanted to fill the entire grid with ever increasing squares, I could just keep on going there and adding square, and I could say square 600, and then I could say square 800, but notice how I'm repeating things again, and notice how there's a geometric progression that I'm doing right here. There's got to be an easier way to do that. Not easier, more elegant, nicer. What we find when we go for the more elegant, nicer ways to do that is that we often come up with something that's much more flexible and capable of doing a lot more than if we go through and hard code everything by hand. Hard coding is functional, it works, but yeah, not very elegant. So what I'm going to do is I'm going to get rid of all this. And now I'm going to make a new variable. And so to make a variable, you have to do a couple of things. Whether you're working in Arduino or just about any programming language, you have to let the computer know that you want a variable, and you have to let it know what its name is. And we will just make a variable called x. Okay, and I will submit that in there. Now we've got a variable in x. Okay, and you'll notice that our variables, just like the L up here, have those rounded edges. So any place where there's going to be a number, you can drag that variable into there. Okay, so we want to make the square keep getting bigger, and we're going to get bigger 200 each time, and we want to do 1, 2, 3, 4, 5, 6, 7, 8 squares. Okay, so I am going to say repeat 8 times. Oh, just a minute, let's break this apart. Put square inside the repeat. Okay, and repeat 8 times. Okay, now, when you start out with a variable, it's a good idea to give it a starting value. Most of the time, a variable will start out at 0, but right down here, we can come in here and say, we want to set my variable. In this case, we're going to set x, the variable that we want, to be 200. We don't want it to start at 0 because a square with length 0 is a pretty tiny square. So we're going to start at 200, and then we're going to come in here. And instead of doing a square with length 200, now we say do a square of length x. Okay, and then each time we do this, okay, what we're going to do is we're going to do a math option here. And we are going to come in here and let's see our operators. Where's all our math numbers? We need a set my variable. Okay. Set x to, and then to do a bit of math, you have to drag these operators in here. Get that one right in there. And we're going to set it to x plus 200. Now, don't try doing this in math class. If you say x equals x plus 200, your math teacher will tell you that that doesn't work. But in the computer world, when you say set x to x plus 200, and the Arduino language, that will say come out as x equals x plus 200. What you're actually doing is saying go take the value of x out of memory, add 200 to it, and then put it back in where the x is. So the first time we run the program, it's going to come in here, and we've said, well, find that memory location called x, put 200 in it. We come down here, we say, what was in that bucket called x? Pull that out of that memory location, use it to execute the square command. Okay, we pass the x over to the command and it comes in here and it gets transferred into a variable called L, and the L is used all the way through our command right here. Control comes back to this program, and now we say go find x again, add 200 to it, put it back into the memory location x, and let's repeat that 8 times. Now, some of these are going to get pretty big and it's going to take a long time to draw. So I don't know if any of you noticed when you were drawing your initials that you can speed things up a little bit because there is a drive velocity command right in here. And let's set that up to 100. And there's also a turn velocity command. And we're going to set that up to 100% as well. Now, what you can see is these are some initial conditions that we're setting up. When it comes time to use our Arduino, we're actually going to have a whole function in the program for setting up our initial connections. And believe it or not, it's called setup. It's actually called void setup bracket bracket, but we'll worry about all those fancy C programming language constructs when we get to it. Right now, this is nice and fun. We've got pictures and colors. Let's give it a shot. I forgot to hit the reset button. Here we go. Okay, so now watching our code right in here, you can see that we're cycling back and forth over in the repeat command over here. And then we come in here. You notice we're driving a little bit faster now, and our squares are getting bigger and bigger. And most of our time in here is in this routine. Every now and then you'll see it flash over to here, and you'll see the repeat function here flash. The square function will be called with the new value, and it'll pass it over here, and this program will carry on running over here. This would be a good time to speed up the video. I don't have a way to speed up this in real time. And anyway, here we go. Now, it's coming along, and it's working pretty good. Okay, hey, actually, I do have a way to speed up time for you. I don't want to stop recording. There is a pause function in here. And we're back. And hey, it looks like it stopped already. How many did I do? I did 1, 2, 3, 4, 5, 6, 7, 8. Oh, what do you know? I had room for a ninth one. So this is where doing your programming parametrically like this with variables and functions is really easy, because if I want to change something now, instead of having to go and add a new command, I just say, oh, I didn't do enough loops. There we go, 9. Yeah, we'll do it. Um, Lots of loops in there. Maybe instead of doing it 9 loops, I want to do 18 loops, but only increase them by 100 each time. Reset all that, and away, here we go. We started at 200, and now we're making smaller circles, or squares, and we're going around here. So being able to program parametrically, being able to create your own functions and routines is a pretty good and useful tool. Now, we've created a square, which is a relatively simple function. How would you go about creating a generic polygon? Okay, so a polygon of any number of shapes. I'm going to let that run in the background, and let's flip back to pen and paper, because a lot of times doing this sort of thing on paper first is going to be your most useful way to go about solving the problem. You've got to think about your code before you start writing your code. So let's take a look right here. Now, if we wanted a generic polygon with side of length L, okay, so our square equals a 4-sided polygon, okay? We call it 5 sides. We've got hexagon, pentagon, I guess. 5 sides, hexagon, 6 sides, septagon, octagon. All right, let's take a look. Well, I guess triangle is our simplest one at 3 sides. It's not really 2 sides. Yeah, that's not really a polygon, that's a line. So let's take a look at a triangle, and how would we go about drawing an equilateral triangle with length L on there? We'd get the camera to focus a bit better. Come on, camera. I think its eyes are getting tired here in the evening. Oh, we had it. Okay, there we go. Maybe if I give it something else to focus on in here, it'll focus on here. So now we've got an angle in here, an angle in here, and an angle in here. And so if we come in right here, you'll notice that on our square, we have an angle right here, an angle right here, angle right here, and an angle right here. And each of these are 90-degree angles, meaning that the internal angles for any polygon are going to add up to 360 degrees because you go all the way around. So inside a triangle right here, this is going to represent, well, we had a 90-degree turn for the robot. It's not going to have quite a 90-degree turn right here. Let's see, this one is going to be a 60-degree turn and a 60-degree turn, and then a 60-degree turn. We're looking for this angle right in here. So it's going to be, let's go ahead and try it. We've got it set up. We can do a whole bunch of things. Now you're sitting there. Is he pretending on the math, or is it just late at night? And he needs another cup of tea. Oh, there we go. Look at that. That guy's all finished doing its drawing right there. Actually, it ran into the wall. We went a little too far. Oh, well, let's close that down now. I'm just going to throw some of this off to the, well, no, I'm not going to throw it off to the side. I am going to redefine this where I can come in here and edit that block. And I'm going to add another input to it. Okay, and I am going to call this sides. Okay, now we're going to put the pen down. We're going to drive forward for L millimeters. Now, however many sides we have, we are just going to drag this down in here. So if I want a three-sided object, then it will repeat 3 times. We'll tell it to repeat over there. And we'll drive forward for our side. And then on here, we're going to put a math operator in here. And let's just try 360 divided by the number of sides. Okay, so let's come in here and let's try making a, we'll get rid of some of the fanciness on there, pop that off. There you go. Whenever you're experimenting with something, you want to keep it fairly simple. Oh, we should have changed the name on here. Let's change that name to Polygon. Okay, in coding, a lot of times people don't like putting in extra characters if they don't have to. So on modern computers, it doesn't matter if you spell out polygon, but on old computers where memory was at a premium, you'd try to keep something really short. So we might only call that PG for polygon. But that was a long time ago where that mattered. Okay, and the first thing we want is the length. So 200. Let's try it with one that we know should work. So always test with something simple. There we go. There is our 4-sided polygon. That worked great. What happens if we try a 3-sided polygon? That looked good. So 360 divided by 3 got us our angles in there. What if we go for a 5-sided polygon? Let's make it a little bit longer. I fell off the board. And that came back looking really, really ugly. Okay, so we've got a little bit of a problem right there, and you can see now why I was concerned about starting in the middle of the screen. So again, we could just do a little bit of Pythagoras, and let's turn again in our initial conditions right up here. Oh, I'm resorting things around there. We'll set our turn velocity, our drive velocity, turn right for 45 degrees to get to the middle of the screen, and then set, where are we here? Set drive velocity. We've got that. Turn right, drive forward for, I think I calculated that out and it was 12. It's like 900 by 900. 1273, pardon me. 1273 should put us right in the middle of the screen. And then if we turn left for 45 degrees, that should have us looking up. Now we can try that polygon in the middle of the screen without going off the edge. Nice. Now, just as we used loops before, we can do a number of interesting little loops with our polygons right here. So for instance, let's bring that down right there and let's repeat this 10 times. Okay. And before we set our starting length to 200. Well, here we're going to keep our edge length the same at 4, but let's change our number of sides. So what we're going to do is we've got this variable called x, okay, right down here. We can still use x, and we're going to start off with x equals 3. Set x to 3, because a two-sided polygon is silly. And then we're going to, what are we going to do right here? We can come in here and we can just use the change my variable as another way to do it. By +1, change x by 1, make sure you've got the right variable. This is incrementing it by 1, so every time we do this, x will go up +1, and let's reset that. Here we go off to the middle of the screen. Oh, it didn't reset our x to 3 for us. Just keeps, oh, that's doing exactly what we told it to. Can you see the error in there? Why am I only getting 5 sides? When I tell the polygon command to execute, we have a constant right in here. What we want is we want to have a variable right in there. So it didn't matter that we changed x if we didn't tell the subroutine that we changed x. Let's try this now. There we go. There's our triangle. There's our square. There's our pentagon. There's our hexagon. There's that 7 side. We're starting to come up with a kind of interesting logo right here. Oh, but we ran out of space. Now things aren't going to line up and it's going to start getting all sorts of ugly. Now, you'll notice that we ran into an unusual condition right there. And quite often, you do run into unusual conditions in subroutines, and sometimes people intentionally try to trigger unusual conditions in subroutines, either crash your program or to hack it out and cause a way for them to be able to break into your program while it's trying to figure out what it's supposed to do. So I was saying on here we could have limits on our sides and what we want it to do. You could do some math in there and you could say, oh, two-sided, thing, that's no good. We're not even going to do that. And you could just reject it. So we could say right here, let's close this. And if we didn't want to do a zero-sided polygon because that's silly, you can put error checking routines in here. And you can say right in here, okay, you can take all that. And you can make sure that this only works if there's our greater than command, if sides is greater than 2, then do all of this. So this checks and makes sure that we're not doing something silly like a zero-sided polygon, a one-sided polygon, or a two-sided polygon, because those just don't really work. Okay, now you could also come up with some math and you could say, oh, is this polygon going to take us off the edge of the board? And if you were, you could return an error message. So we could also have another command in here that comes later on. It says if sides is less than 2, then you could print an error message saying, come on, that's not a polygon. So there's lots of things that you can do in here to check for errors, and filtering out lousy user input is something that that subroutines need to do on a moderately regular basis. None of our programs are going to be subject to a lot of hacking, so it's not really that big of a deal. Oh darn, I forgot to make that screen big again. I did it on one of my screens. I forgot to transition. Gee, now you can see that. That's going to make life a lot better. Um, okay, so just as I was saying on here, we've changed this up, and what we've done is we've set X to 3 sides right in here. We've got a repeat in here so that we're going to now have a second variable in here. X is going to change by 1 each time we loop around these loops right on here. And then we come over here. We've got a function right in here. We pass L and sides to it. We error check to see that sides is greater than 2 because a zero-sided and a one-sided polygon doesn't make sense. And here's our polygon routine all right in here. And that allows us to create a much more complex shape. All right, now here's a little bit of a bigger challenge for you to think about. Okay, how would you make a circle? I don't want just any circle. Okay, I want your circle. And here I have to transition my screen back again, so hold on for just a second. Tell you what I'm looking for. You go up there, back to the pen and paper. Sorry about leaving you on that screen while I was doing things on the other one. I want a circle where your robot starts right here in the middle of the circle. Okay, so I want you to create a circle block. Robot starts at the center. Then the robot's going to drive out to here, right on the edge. And then the robot will put down, it'll come around right here. Return to the center in the same direction and okay, now when you start out doing that, play around with that a little bit. Ultimately, the variable you will pass will be R. This radius right here, you'll tell your robot, draw a circle of radius R. It'll come out here to the edge, go all the way around the outside, come back here, come back to the middle, and then rotate. So if it started out pointing in that direction, then it's pointing in that direction again. Okay. As you go about doing that, you're going to have to think a little bit about how you're going to do that. And it might not be a perfect circle that you're drawing. It might be a 360-sided polygon. and you might turn 1 degree each step as you go around that circle. And that means you're going to have a little bit of a math question on how far you should draw each edge of that polygon. We've already got the command to do this. In fact, it's all worked out. You're just going to have to play around with the math a little bit to make it work. Now, when you get that all worked out, what I want you to do is use your code to use your circle function to create a bullseye. Okay, so I want you to have circle, 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 circle. Let's say 6 concentric circles, just enough that will be a pain in the butt to have to code them all in by hand. Okay, go ahead and give that a try as your initial challenge for today. Once you've got that worked out, I've got something a little bit more entertaining to follow up on that. Okay, so what were we looking at? Subroutines, okay, and variables, very important parts in programming in any language, VEXCode VR, Arduino, setting up a web page. You're going to have subroutines and variables going on in there. We're doing it in VEXCode VR, where everything's nice and easy and drag and drop. Yay, that's great. In more advanced languages, you're going to find that you're typing in on the keyboard a bit more. This is a fun way to get started. Works good with students, and it's good for simple little programs like this. One of the things that you'll find as you get more into your programming, and you'll notice me doing this a lot when we're on here, is that finding the block that you want to drag and drop in there can start to be frustrating. Think about if you were writing an essay and it was drag and drop essay writing, and you had to drag your words off the side. And instead of necessarily being words, they were kind of pictures representing the words, and then they'd turn into words when they came on over here. That would start to get frustrating. And although that would be really great for a little kid starting out, or anybody starting out with a new language. If I had to learn a new language, that might be perfect. It would guarantee that my grammar would be really good and people would be able to understand what I'm saying, because I'd only be able to slap certain words, put verbs into places where they belong, and adverbs into places where they correctly modify the verbs. But in here, we're doing all this dragging and dropping, and it's nice and friendly, and it's got all sorts of colors on it. But we also have all the code that's actually being generated in the background. So never forget that when you're doing all of this coding and you're dragging pretty little blocks in there, you can click over here and see what's going on in the background to turn this into an actual programming language. And this one is based on Python, so it's slightly different than the C-based language we'll be using in Arduino. But you can see that excuse me, we've got a function up here. We've got Polygon right up here. It gets variables called L and sides, and there's a whole bunch of fancy coding coming along in there. And it comes in here. There's our if statement. If sides is greater than 2, if Polygon sides is greater than 2, then there's our pen down. There's our repeat in there, and it'll go through and do all this. And I'm like, why does it have a wait command? We didn't tell it to wait. That must be part of the program's interpretation to make sure it doesn't move too fast and crash itself. And then we come down here, and this is actually where our program starts. It comes in, there's our set turn velocity, set drive velocity. One of the things that as you start getting into more complex programs is that you'll find comments really help. So you can put a comment in here, and the comment doesn't actually get executed. You can just put in here, you can say set up. So if you want to see where something is, you can drag that in there, and you can see that's setting up our initial, okay. And now you can say um, program starts here. And this pops up in your code over there. There's your x equals 3. That's what I said. You're going to see a command that says x equals x plus 1, which makes no sense in math class whatsoever. It's just going out saying, hey, what's an x? Add 1 to it, put it back into x. Okay, and then when everything starts, it starts running all this right in here, calling this routine right in here, and the code passes down into there. But you don't have to look at that for now. We'll do plenty of text-based stuff later on. Circles. Yep. Shrink this window. Right, I'm working on the wrong screen. Too many screens going on. Too late at night. Just make some circles. We'll have another slightly more creative challenge for you a little bit later on.